Hi everyone, welcome to today's GCSE Foundation Revision video. There's 59 days to go into your GCSE Maths exam, and today we're going to be looking at the topic of equation of a line, or y equals mx plus c. If you've got the Corbettmaths revision cards, card number 60, it's going to be a very useful one for you on the equation of a straight line, y equals mx plus c. So in this video, we're going to look at how to answer some questions on it. I'm going to get you to try some yourself at some point, so feel free to press pause and try those, and let's get started.
Hi, today we're going to be looking at the equation of a line. Now yesterday we looked at how to draw straight line graphs, so graphs in the form y equals mx plus c, and we used little xy tables to do that. Now today we're going to be looking at the equation of that line. So here we've got a straight line and it's shown in red, and first of all we're going to look at a thing called its gradient, and its gradient is how steep the line is. Now to work out the steepness of a line we use the formula rise divided by run. So if we do the rise of the line divided by the run of the line, we'll find the gradient of the line. So what you do is you choose 2 points on the line. Now you can choose any 2 points on the line, so I'm going to choose here, I could choose the origin, I could choose the point 1, 2. I'm going to choose this as one of my points, the point 1, 2. I'm going to choose another point. I'm going to choose this one up here, the point 3, 6. Now I've chosen those points because they're quite nice points where it's 1, 2 and 3, 6. I wouldn't choose this point here, for instance, where it's 2 point something and 4 point something, because I want to know where the exact coordinates are. So here we've got 1, 2, and here we've got the point 3, 6. Now if I wanted to work out the gradient of this line, what I'm going to do is I'm going to make a little triangle like so, and I'm going to consider its run, so how far it goes across, which in this case is going from 1 to 3, so it's going 2 across, and its rise, so it's going up 1, 2, 3, 4, so it's going up from 2 to 6, so it's going up 4. So in terms of our line, between this point and this point, the rise is 4 and the run is 2. So the gradient of this line will be equal to, now in terms of gradient, we use the letter m for gradient. The gradient would be equal to its rise, so the rise is 4, divided by the run, which is 2. And 4 divided by 2 is 2. So the gradient of this line is 2. And what that means is for every 1 unit you go across, the graph goes up 2. So if you go 1 unit across, it goes up 2. 1 unit across, you go up 2, and so on. And that's what the gradient of that line is. Okay, let's have a look at another one. So here we've got another line, and if we want to work out the gradient of this line, well, we choose 2 points that are on the line. Now, in terms of choosing 2 points, I think this is a good point here, 0, 50, so 0, 50. And I'm going to choose another point. Now, in terms of our other point, I'm going to choose this one up here. I'm going to choose 25, 250. Now, you may choose other points, but it shouldn't actually matter. As long as you read off the points properly and you do rise divided by the run, you'll get the same gradient. So we've chosen 2 points. Now, let's do a little triangle between those points, so going across. That'll be the run. So we're going from 0 to 25. So the run is 25. The rise, we're going from a height of 50 up to 250. So the rise would be equal to 200. So the gradient, which is m, is equal to the rise, which is 200, divided by the run, which is equal to 25. And if we do 200 divided by 25, that's equal to 8. So the gradient of this line is 8. So that means for every 1 unit you go across, you're going to be going up 8. So across 1, up 8, across 1, up 8, and so on. So for instance, if we go from 0 to 5, that'll be going up 40, and so on. So the gradient of this line is equal to 8. And that's it. Okay, so we've looked at gradient. Now we're going to look at the equation of a line. Okay, so this is part of the Corbettmaths revision card, and this gives us the equation of a straight line. The equation of a straight line is y equals mx plus c, where m is the gradient, so that's how steep the line is, and c is the y-intercept, that's where the graph crosses the y-axis. So if we have a look at this line that's been drawn for us, its y-intercept is 1, it crosses the y-axis at 1, so it's plus 1, its y-intercept is 1. And then in terms of its gradient, how steep the line is, we can choose 2 points, and if we choose this point, which is the point 1, 3, and if we choose this point up here, which is the point 3, 7, it's got a run of 2 and a rise of 4, and if we do 4 divided by 2, that's equal to 2. So the gradient of this line is 2. For every 1 unit you go across, you go up 2, across 1, up 2. So that means that this graph has got an equation, y equals 2x plus 1, because 2 is the gradient, and 1's where it crosses the y-axis. So this is the equation of a straight line, y equals mx plus c. Now it's really important you know this equation of a straight line. If you've got window pens, write on your window, or if you've got the revision cards, get people to quiz you on it, make sure you know that m is the gradient and c is where the graph crosses the y-axis. Okay, let's have a look at a question now. Okay, so if we had a straight line that had a gradient of 8 and a y-intercept of 4, what would the equation of that straight line be? So feel free to press pause now and write down the equation of that line. Okay, so a straight line's got an equation, y equals mx plus c. That's the equation of a straight line, where m's the gradient and c is the y-intercept, where it crosses the y-axis. So m's the gradient, so this line's got a gradient of 8, so it's going to be y equals 8x. And then plus c, well, it crosses the y-axis at 4, so it'll be plus 4. If the gradient was 7, it'll be y equals 7x plus 4, and so on. If the y-intercept was 17, it'll be 8x plus 17. If the y-intercept was minus 3, it'll be y equals 8x subtract 3, and so on. Okay, so if you got that, well done. Okay, so this time a line's been drawn for us, and we're going to write down its equation. So let's see how we'd write down the equation of this line. So if I want to write down the equation of this straight line, what I would do is I'd write down y equals mx plus c to begin with, just to remind me that's the equation of a straight line. line, where m's the gradient and c is the y-intercept. So in terms of this line, let's consider the gradient and the y-intercept. So the y-intercept is going to be 4, so it's going to be y equals something x plus 4 because it crosses the y-axis of 4. Let's find its gradient. So I'm going to choose this point here, and I'm going to choose this point here. I could have chosen any 2 points on that line, but I've just chosen that one and that one, the point -1, 1 and 1, 7. So I'm going to draw a little right angle triangle, so like so. And it's a right angle triangle. And in terms of the run and the rise, well, the run, it's going 2 units across, so it's going to be 2. So it's runs 2. And in terms of the rise, it's gone up from 1 to 7, so it's going up 6. So the rise is 6. So the gradient of this line, m is equal to the rise divided by the run. So the rise is equal to 6 divided by the run, which is 2, and 6 divided by 2 is equal to 3. So the gradient of this line is 3. So the equation of this line would be y equals, instead of mx, we're going to write 3x. And then instead of plus c, we want to find where the graph crosses the y-axis, which is 4. So plus 4, and that's it. So the equation of that line would be y equals 3x plus 4. And if you got that, well done. So the equation of that line would be y equals 3x plus 4. Okay, let's have a look at another one. Okay, so this is one for you to try now. Here's a line. Can you write down the equation of that straight line? Okay, so the equation of this line would be y equals mx plus c. It'd be in the form y equals mx plus c. Let's find the gradient and then let's find the y-intercept. So the gradient, the gradient is rise divided by run. So let's choose 2 points on this line. So I'm going to choose this point here, the point 0, 5. So that's the point 0, 5. And I'm going to choose this point here, the point 1, 7. So I've chosen 2 points. I'm going to make a little right angle triangle. And the run, well, we're going from 0 across to 1, so the run's just 1. And the rise, we're going from a height of 5 up to 7, so the rise is going to be 2. So we've got m, the gradient, is equal to the rise divided by the run. So we've got 2 divided by 1, and 2 divided by 1 is equal to 2. So the gradient of this line is 2. So in terms of the equation of this line, it's going to be y equals, instead of mx, we're going to write 2x. And then plus c, well, it crosses the y-axis of 5, so it'll be plus 5. And that's it. So the equation of that line would be y equals 2x plus 5. And if you got that, well done. Okay, let's have a look at another question. Okay, let's have a look at another one. So this is another one for you to try. Now, just before you do this one, I want you to be careful with this horizontal scale. So whenever you're going 1 unit across here, you're going from 1 unit across. That's going to be 2 little boxes. So just be careful with that. Okay, so if we wanted to find the equation of this line, it'd be y equals mx plus c. That's the equation of a straight line. So we need to find m, the gradient, and c, the y-intercept. So let's find the gradient to begin with. So let's choose 2 points. I'm going to choose this point, 1, 0. So that's the point 1, 0. And I'm going to choose this point up here. This is the point 3, 8. You could have chosen other points, but I've just chosen those 2. Now let's do a little right angle triangle. So going across and up, and there's a little right angle triangle. Now in terms of the run, we're going from 1 to 3, so we're going 2 units across, so it's not 2 squares, it's 2 units across. From 1 to 3, we're going across 2. And in terms of the rise, we're going from height of 0 up to 8, so that's equal to 8. So the rise is 8, from 0 up to 8. So then we're going to do the gradient, m is equal to the rise divided by the run. The rise is 8 divided by the run, which is 2, and 8 divided by 2 is 4. So the gradient of this line is 4. So it's y equals 4x. Now let's find our plus c where it crosses the y-axis. It crosses at -4, so it'll be -4. So the equation of that line is y equals 4x minus 4. And if you got that, well done. Okay, let's have a look at another question. Okay, this time we've got a line that's going downwards, so this one's going to have a negative gradient. So feel free to press pause and try this question now yourself, or in a second I'm just going to go through it, so you can watch if you want to, or you can try it yourself. Okay, so in terms of this line, this equation would be y equals mx plus c. We need to find its gradient and the y-intercept. So let's find its gradient. The gradient is equal to the rise divided by the run. So the rise of this line, let's choose 2 points. So I'm going to choose this point here. This is the point -1, 4. And I'm going to choose this point here, which has got coordinates 2, 1. So in terms of the rise and the run, let's turn it into a little triangle. So I'm going to go across and I'm going to go down. So in terms of the run, we're going from -1 across to 2. So the run is 3. So it's 3 across from -1 to 2. It's 3 across, not 3 squares, 3 units across. So 3 across. And in terms of the rise, well, we're going from 4 down to -1. So its rise would be -3. We're going down 3. So the rise is -3. So we get -3 divided by 3. And -3 divided by 3 is -1. So the gradient of this line is -1. So we've got y equals, now instead of mx, we're going to write the gradient. So it's going to be -1x, but we tend not to write -1x, we just write -x. And then we've got our plus c, that's where it crosses the y-axis. That's going to be 3, it crosses the y-axis of 3, so plus 3. So the equation of this line is y equals -x plus 3. And if you got that, well done. Okay, let's have a look at another one. Now this time we've not been given the squares, we've just been given a little sketch. And I want us to find the equation of this line. So feel free to press pause and find the equation of this line. Okay, the equation of this line will be y equals mx plus c. We need to find m, the gradient, and c, the y-intercept. Now c is quite easy. It's going to be -1. It crosses the y-axis at -1, so it'll be -1. But let's find its gradient, m. M is equal to the rise divided by the run. So let's do our little triangle. So we're going to go across and we're going to go up. So in terms of the run, we're starting at 0 across. We're going to 5 across. So the run is 5. So we're going 5 along the corridor. And in terms of the rise, we're going from height of -1 up to 9. So from -1 up to 9, we're going to be going up 10. So m, the gradient, will be the rise, which is 10, divided by its run, which is 5. And 10 divided by 5 is 2. So the gradient of this line is 2. So that means its equation will be y equals, instead of mx, we're going to write 2x. And then plus c, that's where it crosses the y-axis. It crosses at -1, so it'll be -1. So the equation of this line is y equals 2x minus 1. And that's it. And if you got that, well done. Now, before we carry on, I just want to have a look at one type of question. Okay, now sometimes we might be given an equation of a line and we might be asked if a point lies on a particular line. So this question says, does the point 57 lie on the line y equals -3x plus 22? So if you want to have a go at this, feel free to press pause and show whether this point, whether it lies on the line or doesn't lie on the line. So if I want to find out whether this point lies in this line or not, I'd consider the point to begin with. So we've got the x-coordinate, which is 5, and the y-coordinate, which is 7, because remember, it's along the corridor and up the stairs. So the x-coordinate is 5 and the y-coordinate is 7. And we're going to substitute those into the equation of the line. So instead of y, we're going to write, we had y equals -3x plus 22. So instead of y, we're going to write 7. So we've got 7 equals, and then -3x, that's -3 times x. Now x is 5, so we're going to do -3 times 5. And -3 times 5 will be -15, so that's -15. And then we've still got our plus 22. So we've got that 7 equals -15 plus 22. Now, if this point lies on this line, we'll get that 7 equals 7. And if this point doesn't lie on the line, we'll find that 7 equals something else, and then this wouldn't be correct, so then this wouldn't be true. So let's find out if 7 equals -15 plus 22. So we know that we've got 7 on the left-hand side, so let's work out this -15 plus 22. Well, if we're at -15, if we go up 15, we get to 0, and if we go up another 7, we get to 7. So -15 plus 22 is 7, so we get 7 equals 7. So does the point lie on the line? And that's it. So I've just written down yes, 5, 7 does lie on the line, y equals -3x plus 22. And that's it. Okay, let's have a look at this question. So this time we've been given a straight line has gradient 3 and passes through the point 1, 5. Find the equation of the line. So the equation of the line is going to be the form y equals mx plus c. So that's the equation of a line, and I would write that down to begin with. Now we want to find its gradient. Actually, we know its gradient. It's going to be y equals 3x plus c. That's fantastic. Now in this question, we just need to find the y-intercept. But unlike the last one where we knew where it crossed the y-axis, this time we don't know where it crosses the y-axis. We just know that it goes through the point 1, 5. Now there's two different ways we can find this y-intercept. Now one way you could find where it crosses the y-axis is to consider what the graph looks like and do a little sketch. So you could do a little sketch like this where we've got our x-axis and our y-axis. We know the line's got a gradient of 3, so it's got a positive gradient, it's going up this way, and it passes through the point 1, 5. So it passes through the point 1, 5. That means that because the line's got a gradient of 3, that it's started somewhere on the y-axis and it's going to cross 1 and up 3. So if it's going to cross 1 and up 3, it would have had to pass through the point 0, 2, because that would have been 1 across and 3 up to bring us to 1, 5. So we know that the graph will cross through the y-axis at 2. So that means the equation of this line will be y equals 3x plus 2. And we just done that by considering where 1, 5 would be. It'll be just 1 unit across from the y-axis. So if we go back 1 and down 3, we'll find out that it passes through the point 0, 2. And that's how we found that the y-intercept was equal to 2, and then its equation would be y equals 3x plus 2. Now that's quite nice for this question because this point was really close to the y-axis. We could just go back 1, down 3. If it was 2 across on something, you could go across 1, down 3, across 1, down 3, and you could find out where it crosses the y-axis. But what if this was 17 something or other? You don't want to do that 17 times. So there's another way you could find the equation of this line. So I'm going to go back. So here we had y equals 3x plus c. So because we know the gradient of the line is equal to 3, so we've got y equals 3x plus c, and we want to find the y-intercept. Now this point has got an x-coordinate of 1 and a y-coordinate of 5. If we substitute these into the equation, we can find out what c is, which is the y-intercept. And then that means we can then find the equation of the line. So let's substitute x equals 1 and y equals 5 into the equation. So y is equal to 5, so we get 5 is equal to 3x, so that's 3 times 1, and 3 times 1 is equal to 3, plus c. So we get the 5 is equal to 3 plus c. Now we just solve this, we take away 3 and take away 3 from both sides of the equation. 5 take away 3 is equal to 2, and that's equal to c. So we get the c is equal to 2. So we've got the y is equal to the gradient, that's 3x, and then we've got our plus c, that's where across the y-axis, which is 2, so plus 2. So that's the approach I would use. I would label the x-coordinate and the y-coordinate and substitute those in to find the c, and then just write down the equation. Okay, let's have a look at our next question. So this time we've got a straight line's got a gradient of 7 and passes through the point 210. Find the equation of the line. So we know it's going to be in the form y equals mx plus c. That's the equation of a line, y equals mx plus c. We know the gradient's equal to 7, so we get y equals 7x plus c. Now we want to find c where it crosses the y-axis. Now we've got two approaches we could use. We know that the point's at 210, so we can consider where it is. We've got this point 2 across 10 up, so it'll be up there somewhere. So because the line's going to gradient is 7, we could go back 1, down 7, so that'll bring us to the point 1, 3, and we could go back another 1 and down 7, that would bring us to 0, negative 4. So it crosses the y-axis at negative 4, so it's going to be y equals 7x minus 4. So that's one approach. I personally like to call this x and y, the x coordinate and the y coordinate, because I know the line passes through this point, so we can then substitute these into the equation. So instead of y, we've got 10 is equal to 7x, that's 7 times 2, which is 14, plus c. And if we take away 14 and take away 14 from both sides, we get 10 take away 14 is minus 4, and on the right hand side we get that's equal to c. So we get the c is equal to minus 4. So that means the equation of this line would be y equals 7x minus 4, and that's the equation of the line because its gradient is equal to 7 and its y-intercept is equal to minus 4. And that's it. Okay, let's have a look at our second last question. So this is a question for you to try, and we've got a line and it passes through the points 1, 13 and 3, 19. So can you find the equation of that line? So feel free to press pause and to try this question now. Okay, so if we want to find the equation of this line, we'd write y equals mx plus c. And we want to find the gradient of this line and the y-intercept. So let's find the gradient to begin with. So let's draw a little triangle and a little right angle. And in terms of this triangle, we're going from 1 across to 3 across. So its run is equal to 2. And its rise, it's got a height of 13 and it's going up to 19. So the rise would be 6. So the gradient m is equal to the rise divided by the run. So rise divided by run. So that's equal to rise, which is 6, divided by the run, which is 2. And 6 divided by 2 is 3. So the gradient of this line is 3. So we've got y equals 3x plus c. Now we want to find where it crosses the y-axis. Now there's a couple of approaches you could use. Remember the gradient's 3, that means we go across 1, up 3, across 1, up 3, across 1, up 3, and so on. So if we go back 1 and down 3, we can find this point, and this would be the point 0, 10. So that means its y-intercept is 10, so it would be y equals 3x plus 10. So that's the equation of the line. So that's one approach to find the equation of that line. Another approach is to consider one of the points the line passes through. Now we've got a choice of 2 here. We can choose point B or point A. Now I'm going to choose point A and I'm going to label the x coordinate as 1 and the y coordinate as 13. So let's substitute those in. So y, that's going to be 13, equals 3x, that's 3 times 1, which is equal to 3, plus c. And then if we take away 3 and take away 3, we get that 10 is equal to c. So that means the graph crosses the y-axis at 10. So that means its equation is y equals 3x plus 10. And if you got that, well done. Okay, let's have a look at one last question. So this is our last question. So this time we've got a straight line passes through the points 3, 8 and 5, 20. Find the equation of the line. So feel free to press pause and to find the equation of this line. And if you need a wee hint, my hint is draw a little sketch. Okay, so if I was doing this question, the first thing I would do is I would draw a little sketch just to see what it would look like. So let's get our y-axis and our x-axis sketched. So let's just sketch where our points might be. 3 across and 8 up, well, it might be there somewhere. And 5 across and 20 up would be up there somewhere. And that's our little sketch where those points might be. Now, they might not be in exactly the right position, but it's just a little sketch. Just the point 3, 8, and the point 5, 20. So we want to find the equation of the line. That's y equals mx plus c, where m is the gradient and c is the y-intercept. So let's find the gradient to begin with. So we've got our little triangle. And we're going from 3 across to 5 across, so the run's 2. And we're going from a height of 8 to a height of 20, so we're going up 12. So we've got m, the gradient, is equal to the rise, which is 12, divided by the run, which is 2. And 12 divided by 2 is equal to 6. So the gradient of this line is 6. So it's y equals 6x plus c. Now, in terms of finding the c where it crosses the y-axis, you've got a few different approaches. You could go back 1, down 6, back 1, down 6, back 1, down 6. That would work. Alternatively, I'm going to choose one of the points. I'm going to choose this point here, the 520, and I'm going to label it x and y. I'm going to substitute those in. So y, which is 20, is equal to 6x, that's 6 times 5, which is 30, plus c. We want to find out what c is, so we don't want this plus 30, so we're going to take away 30 and take away 30. 20 take away 30 is negative 10, and that's equal to c. So that means the equation of this line would be y equals 6x, because it's got a gradient of 6, minus 10, because it crosses the y-axis at minus 10. So the graph would look something like that. And that's it.
And that's it. So in this video, we've looked at the equation of a straight line, y equals mx plus c, where m is the gradient and c is the y-intercept. Hopefully you found this video useful. It's one of those topics that I highly recommend practicing because the more practice you do on this, the better, the more confident you'll become on it. So in the description below, there's a link to the practice questions, so hopefully they'll be really useful for you as well. So as I said, there's 59 days to go until your GCSE exams. Keep up the hard work. You're doing really well, and I'll see you tomorrow for the next video at 3 o'clock on YouTube. Cheers. Bye.